Hi class. In this lecture, I will talk about some basics of network and the transportation problem. So key of this lesson has two parts. The first part, you will know some terminology and symbol or graph representation of the network. And the second one, I will talk about the definitions of transportation problem and the mathematical model for transportation problem, and use games and Excel to solve the example transportation problem. We start from know the basic elements of the network. Network model included nodes. Sometimes we will call it vertex or point, which are connected by arcs, and arcs we sometimes will call it links, edges, lines, or branch. An arc has a single direction, which represented by arrow. A line segment without any arrow means undirected arc. If a network includes undirected line segment, this network is called undirected network. If the network has all arrows, all network is called directed network. And if a network has undirected and directed like arrows, the network is called mixed network. A directed arc can be represented by two directed arcs like this. Okay, this one without any arrow. Then we use this arrow and this arrow, so bidirection, to represent undirected line. Okay, and for the arc, it doesn't matter use straight line, curved line, or like this without any shape. Okay, very complicated. Basically, it's the same. So normally in the network, we will use the straight line or curve to represent arc. There are two categories of the network. One is undirected network. The application we all sometimes we use the tree application. Later on, I will talk about minimum spanning tree as an undirected network. Directed network has two kinds of network. One is uncapacited network. Every arc has a number to represent distance, cost, time, or profit. And the second kind is capacited network. Every arc has at least two numbers. One could represent unit cost. Other could represent upper limit. Even there might be third numbers, which is the low limit of the flow. For the uncapacited network, there are shortest path problem or traveling sales problem called TSP. Capacity network includes maximum flow problem or minimum cost flow problem, which is transportation problem. And in this lecture, I will talk about the transportation problem first. So basic terminology and symbol for the network, we always use the graph. We use the G, represent a network. Within this network, there are nodes and the arc. So we will use the G and A represent a network. And the arc, we will use parentheses ij to represent node I to node j. So first, I introduce the simple trend. The simple trend has no repeated nodes. Like we start from the node x1, then arc e1, then node s2, till node x6. But for the non-simple trend, we will find here there is a cycle there. So simple path example is in the left graph here. We start from the x1, then to the x11, and we don't need to care about the direction of the arc. Okay, and for the cycle, it's the same. Okay, they have the start and end points are the same, means the cycle. And in the cycle, we don't need to consider the direction of the arc as well. Subnetwork. The subnetwork is something like that. We call that F is the subnetwork of the G. Okay, and G is represent NA, and F is represent NA bar. Okay, so we see in the subnetwork the nodes totally the same, but the arc are partial of the original arc set. For the partial work, we call it E is the partial work network of the network G. Okay, so we can see the node set is part of the original node set, and the arc are partial of the original arc for these two, but it can exist the arc here not in the original arc set. We call this kind of the network called partial network. And if we combine these two together, we call it partial subnetwork. So H is the partial subnetwork of the G. Okay. And for the tree, what is the tree? Tree is a graph that all the nodes are connected by the arc without any cycle. Okay, so H basically is a kind of tree. So all of this network normally can apply in a lot of the domain, especially for supply chain models. So what is the supply chain model? Supply chain model describes the set of all interconnected resources involved in producing and distributing a product. So here resource, we might be means the plant or distribution center and so on. So it's something like the node, right? And because all of the resources are interconnected with each other, so interconnect each other means there should be a route or route between different resources. So you can use the arc in the supply chain to describe the supply chain model. Okay, so basically supply chain models is a kind of network. Okay, here is an example says a supply chain for automobile industry could include raw material producers, automobile parts supplier, distribution center for sorting automotive parts, assembly plants, and car dealerships. All the material need to produce a finished automobile must flow through the supply chain. So this very simple example describes the automobile industry. It belongs to the supply chain model, which can be represented by the network flow model. Okay, so in general, the supply chain are designed for satisfy customer demand for a product at a minimum cost. So this kind of supply chain model, normally we can transfer the supply chain model into the transportation problem. So what is the transportation problem? Transportation problem arises frequently in planning for the distribution of goods and services from several supply locations to several demand locations. Typically, a quantity of goods available at each supply location, we call it origin, is limited. and the quantity of goods need to at each of the several demand locations, we call it destination, is known. The usual objective in transportation problem is to minimize the total cost from the origin to the destination. Of course, if you know the profit of the arc, you can use the objective with maximizing profit. For transportation, there are three case scenarios. The first case is supplier quantity equals to demand quantities. And the second case scenario is the supplier quantity is larger than demand quantity. And the third case scenario is the supplier quantity is less than the demand quantity. I start from the supplier quantity equals demand quantity. Okay, we can show we can see the right side graph here, which represents abstract of the network flow model to describe supply chain model. Okay, so for each node, we have the plan 1, 2, 3 for the origin. Okay, and for the destination node, we can use the distribution center to describe it. We have the 4, 1, 2, 3, 4. And for node and node, we have an arc linked with each other, and for each arc represent the transportation 1 unit's goods from the origin to the destination node. Okay, so the 5,000 here is the supplier quantity of the first plant, and the 6,000 here is the demand quantity of the distribution center. Okay, so in this problem, we try to find how plants ship their goods to different distribution centers so that all the total cost is minimized. In order to solve the problem, we can build a mathematical model. We start from definition of the sets, parameter, decision variable. Okay, so I represent the plan, which is origin. I from 1 to here should be n, and the destination should be m. Okay, sorry for the title. And the j is the destination, j from 1 to m. And the SI means production capacity of the plant I. DJ means the demand of distribution center J. CIJ means the cost, unit cost to ship one product from the origin I to destination J. And the Xij is the decision variable, which means the number of units shipped from the origin I to destination J. For example, X11 means the number of the units shipped from the origin 1 to destination 1, which means the plant 1 to the distribution center 1, okay, and so on. And then now we try to build the mathematical model. Okay, basically this one minimizes z, Cij, Xij here is the objective function here. And the production capacity constraint is here. And the demand of distribution capacity constraint is here. Okay, we can, for example, this one, Si, which means the supplier of the plant I. Okay, so Xi1 means the plant I shipped to the distribution DC1, right? And this one is plant I ship goods to DC2. Okay, so total ship out should be has the same quantity as the supplier quantity. And for the demand is the same. Okay, J is a specific DC. Okay, then 1J means the first plane. Ship the quantity shipped from first plane to the J. And X2J means the second plane ship the quantity to the distribution J. Okay, so this one is the total received quantity from different planes. So then we sum together. Okay, but if you are find in this way is not easy to understand, we can try to build a metric representation and then build a model in order to let you more familiar with the mathematical model construction. Okay, so here is the table, and for the column here 1, 2, 3 means the plane. Okay, and it has a corresponding supplier which is 5,000, 6,000, 2,500. Okay, and here for this row 1, 2, 3, 4 means the distribution center 1, 2, 3, 4, and it has corresponding demand for 6,000, 4,000, 2,000, and 1,500. Okay, and in each cell here means the unit cost shipped from plane I to distribution center J. Okay, for example, this number means the unit cost from plane 1 shipped to the DC chip. Okay, and this number is plane is the unit cost from the plane 3 to DC 3, right? So now we try to put decision variable into cell. So this one is x11, x12, x13, x14. We only consider the first plane. Then we change the first plane to plane I. Okay, so S11 means the first plane ship the quantity to DC1, right? So this one is DC2, DC3, and DC4. So we added all x together means the total supplier number should be to the total number should be the same. Okay, so we added these 4 numbers together. Right, should be together. Okay, ship out equals the total capacity, right? Then we change the index, first the index of x to I, right? So it's xi1 plus xi2 plus xi3 plus xi4 equals to si, right? Yes, S1. Okay, then we use the summation to represent this one. So it will become the summation J1 to 4, right? And the Xij equal to Si. Okay, this one is the constraint listed here, which is exactly the same with this constraint. Okay, and for the distribution center, we use the row, use the column, right? Then we write down here is 2, 1 and 3, 1, and this one is D1, right? So this one will be the x11 plus x21 plus x31 equals to D1, right? Then we change the J equals to 1 to J. Okay, so here we change to 1J plus x2J plus x3J equals to DJ, right? Then we use the summation symbol. Here is I equal to 1, 2, 3, xij equals to dj. Okay, so this constraint exactly the same here, right? Okay, so this is the way we can construct the mathematical model. Okay, so what if the supply quantity large than demand? Okay, so we have the more quantity, but we have less demand. So fulfill the demand, still left some quantity that cannot ship out. Okay, so where this extra quantity go out, maybe we can take a strategy that we added one more demand, pseudo demand, and put all the quantity to the pseudo demand side. Okay, so it's something like that. We added one pseudo destination 0, okay, and the demand capacity is the difference between the capacity and the demand. Okay, in this case is 3000. Okay, then we change the index for j equals to 1 to j equal to 0. Okay, in the objective function there and the constraint there. Then we automatically solve the problem. Okay, so we added one pseudo demand distribution center here, and its quantity is the difference between the total capacity and the total demand. Okay, and for the third case, basically it's very similar to the second case. Now we don't have enough capacity to fulfill the demand. Okay, so here demand is more and the capacity is less. So we added one pseudo supplier node to represent the quantity we cannot fulfill with. Okay, and remember all of the arc in case 2 and case 3 we should be put the 0 because we cannot influence the objective value. Okay, so this should be very careful about. We just make the flow become balanced to that the mathematical model will not be invisible. Okay, so that's our purpose. Okay, so the cost should be set to be 0. Okay, so in the table we added one row for the plant. Okay, and in mathematical model we changed the I start from 1 to 0, right? And here I original is 1, then we change 1 to 0. Okay, so this is the mathematical model for transportation problem. So now I'll take you step by step to build the transportation model into the games and the Excel to solve this problem. Okay. We go to the games first. Okay. So first we have plan I, right? So we use the sets. We have the I 1, 2, 3, and we have DC 1 to 4. Okay, and also we have the supply and demand. We can use the parameter to declare the supply and demand. So we use the parameter. We have a supply I for the first plant. The capacity is 5,000. For the second one is 6,000, and the third one is 2500. And for the demand, J, the first one is 6000, and the second one is 4000, and the third one is 200, and the fourth one is 1500. And because the cost is something like matrix, right? So we use the table to describe it. Cij 1, 2, 3. 1, 2, 3, 4. 3, 2, 7, 6, 7, 5, 2, 3, 2, 5, 4, 5. Okay. Once you finished, if you are worried about you input the round number, then you can display SDC to check if your number is correct or not. Then you can run the model, and the CS, CD, and the C. Okay, you can check the number. If something wrong, you can re-input the number. Okay, then we define the positive variable Xij to represent the quantity shift from plane I to the distribution J, right? And we need the objective value Z to calculate the total cost. Okay, then we define the equation objective, and we have a supply I and the demand J. Okay, and we can define the total cost is equal summation Ij Cij times Xij, and for the supply we have sum all the J Xij together. You can refer the matrix I try to build the mathematical model, the table, remember, here. Okay, here you can just use this concept, and you will know why I write the mathematical model in games code. It's something like that. Okay, is equal to supply, and for the demand is sum I Xij equal to Dj. Okay, then I name the model called transportation, and I want to solve all the constraints. And I want to solve it. Okay, so I solve it. Oh, something wrong. Again, I think should be somewhere around. violation for the sets. Okay. Oh, here should have a comma here. Sorry, typo. Okay. So the objective value is 39,500, and we'll see the x here. So we can write down the answer and check if it makes sense or not, right? So x11 equals 3,500, x12 is 1,500, s22 is 200, $2,500, x23 is 2,000, s24 is 1,500, x31 is 2,500. Okay, so we can put all this number into our table here to check if the results make sense or not. So I clean this table. So I just write down it. x11 3,500, s12 is 1,500, s22 here is 2,500, s23 is 2,000, x24 is 1,500, and the x31 is 2,500. Okay, so you can check and edit the number by column and by row. For example, you can check this column. So 3,500 plus 2,500 equals to 6,000, right? So the result is correct. And then this one, you can check this row. 3,500 plus 1,500 equals to 5,000 is correct, right? So you can check this one, right? So these three numbers added together is 6,000. It's okay. So this number equals to this number is okay. And we added these two equal to 4,000. And this one is 2,000. This one is 1,500. So the result is totally correct. Okay. So now I built the mathematical model by Excel and solve it in Excel solver, because this layout a little bit different than what I have already told you in the previous lecture. Okay, so we go to the Excel. Okay, here. So now we have the 1, 2, 3. Here we call it Xij. 1, 2, 3, 4, right? So we start from all the number is 0. Okay, and we need to sum of this row together and edit it to see if it is equal to the supply, right? So here is sum of this one, right? Will be equal. So we have a 5,000, 6,000, and 2,500. Okay, and also we added column, right? Added column together to see if it fulfill with the customer demand, right? So here is 6,000, 4,000, 2,000, 1,500. Okay, so we use here, and we copy from here, right? Okay, and we also need to calculate the objective value, right? So we still need a table for Cij. 1, 2, 3, 4. Okay, and we'll put all the number, unit cost number there. Okay, so we use the sum product, okay, sum product of this matrix and this matrix to get the objective value. And maybe I just put objective value here and highlight it. Okay, sum product. So all of these matrix times here. Okay, so we already finished the layout of the transportation problem. Okay, then we go to the solver, which is in here. You have a solver. If you don't have solver, remember, go to the option. Go to the option and go to the add-in and choose the Excel solver. Yeah, here. Sorry, it is in the Chinese, but it means Excel solver. Then you put, you enter, and you will find the Excel solver in the data tab here. Okay. And our objective is here, right? Objective value is here, and we need to minimize. So we choose the minimize, and all the decision variable is in this matrix, right? And we have this supplier constraint equal this one, right? And the demand constraint here equal this one, right? Okay, so I think this is not correct. I delete it. Okay, I check again. G3, okay, D3, where is D7? Oh, maybe I need to delete again and input again to avoid mistake. I8, okay, C3, F5, C3, F5, okay, then G3 to G5 equal, then these three number, okay, and this one is equal, and this one, okay, I think should be correct. And choose the simplex LP, then press enter, and you will get the number. Objective value is 3 39,500, which is exactly from the games, right? So we go to the games, it's the same. And for the value decision variable here, let's see. Okay, so x11 is 3,500, x12 is 1,500, and x22 2,500, x23 okay 2,000, x24 is 1,500, and the x31 is 2,500, which is exactly what we get from the games, totally exactly the same. Okay, so in this lesson, I talked about the network basics, and you know the symbol and how to use the abstract symbol to represent the network. And then I talk about some category and application belongs to the network flow. And normally, I think supply chain model always can use the network model to solve it. And I start from the transportation problem and teach you how to build a mathematical model in the first case. And there are other two cases, which is the supply quantity larger or less than demand. You need to edit pseudo destination node or pseudo origin node. And setting all the arc, the cost is 0, then you can use the first case mathematical model to solve it. And I also bring you step by step to construct the mathematical model by games and Excel. And you will find the result exactly the same. But beware of that because the variable and constraint in Excel solver are limited. So it is better for you to use games to solve a little bit larger size problem instead of use Excel. Okay, that's today's lecture. Hope you enjoy the games and Excel. Okay, bye bye.